Okay, in this session we will discuss our first graphing method, which is table of values. Alright, table of values. Excuse me. And really all we're talking about with a table of values is a table that's constructed with x and y values that is related to some equation or function. So let's say we have the equation 3x plus y equals 12. Alright, now in the event that you're given an equation and you're asked to, let's say, complete the table of values, where you're given some values already. Okay, so you're given an equation, 3x plus y is 12, and you're given a incomplete table of values, and this is what we're calling our table of values, where we have a number here for our x, this -1 is for our x, and this 6 is for our y. All they're really wanting you to do is to take these values that are given in the table and to find these missing values. Okay, so in order to find this first missing value right here, we're looking obviously for y, because the blank space is in the y column. All of the values on this side are y, all of the values on this side are x. So we have an x of 0, we want to find y. So all you end up doing is taking this that you're given, in this case an x, plug it into your equation. So instead of 3x, now I'm writing 3x because x is 0. 3x plus y equals 12. Now 3 times 0 is 0, so that basically cancels, and so you're just left with y equals 12. So if x is 0, then y equals 12. So if x is 0, then I put 12 over here. Okay, now for the next one, I'm given a 6 and I'm needing to find this x because my 6 is under the y column. So now it's telling me that y is 6 and I need to find an x. So again, I go back to my initial equation, 3x plus y plus, and I put it in parentheses to show you that I'm plugging it in, 3x plus y, because we're saying now y is 6, so 3x plus y equals 12. And so I'm trying to solve for x, so I subtract 6, my 6's cancel. 3x equals 12 minus 6, which is 6. Get x by itself, divide both sides by 3, 3's cancel. X equals 2. So when y is 6, x is 2. So now we found that blank, or the 2 there. Okay, so lastly, to complete the table, we need to find a y when x is -1. When x is -1, basically this is saying, what would y be? What would y be if x is -1? So again, go back to your initial equation, 3x, because we're saying x is -1 now. So 3x plus y equals 12. 3 times -1 is a -3, plus y equals 12. Add 3 to both sides, y equals 15. So when x is -1, y is 15. Alright, so that's just a basic exercise of completing a table of values. So again, all you would do is plug in the values that were given to you, and that will help you find the values that were missing, which in this case were those values. Alright, now we initially said that table of values is what we're going to say is our first graphing method. Alright, so let's talk about table of values as it relates to actually constructing, helping us to construct a graph. Okay, so let's erase some of this. Now, when we're talking about using table of values to help us construct a graph, a couple of steps that I would ask that you follow. First being that you want to solve the given equation for y. Okay? You want to solve the given equation for y. Alright. Now, in doing so, all other terms that would be on the other side of the equation from y would typically consist of an x term and a constant term. So what I want you to get in the habit of doing, for purposes that will be revealed in a later lesson, is we want to get in the habit of writing the x term before the constant. Alright? We want to make a point of writing the x term before the constant on the other side of the equation as we solve for y. Okay? Now, after we've solved for y, we can construct our table of values. And once we construct our table, we plug in our x's. Alright, plug in our x values. Okay. Plug in our x values. Alright. Calculate y. And then last, plot x and y values as points and graph. Okay? Plot x and y values as points and graph. So these are the steps we want to follow for graphing using table of values. So you want to solve for y and make a habit of making sure you put the x term before the constant term on the other side of the equation from y. Construct your table, plug in your x values, solve for y or calculate your y, and then plot your x and y values from your table of values as points on a graph. Okay, so let's look at our first example. Let's say we have 2x plus y equals 5. Okay, now the first step says solve for y. This equation is not currently solved for y. Y is not by itself, so we need to isolate the y, get it by itself. So what we would do is get rid of this x. So I would subtract x from this side and subtract x from the other side of the equation. So now my y is by itself on the left side of the equation. There's nothing on this side of the equal sign. Say the equal sign. There's nothing to the left of the equal sign but y now. And that's the point. When you're trying to solve for something, you want to get whatever it is that you're trying to solve for on one side of the equal sign by itself. And on the other side of the equal sign, you see we have the 5 and the minus the 2x that we took from over here. So 5 minus 2x. And because these are not like terms, we cannot combine them. so we simply write them out. But now we refer back to our note, which says write the x term before the constant term. So I want to write the x term, in this case is a negative 2x, before my constant term. My constant term is just that positive 5. So there it is. There's my equation. Y equals a negative 2x plus 5. So I've done step 1. Alright, I've solved for y. So now I can construct my table. Now this is critical that you make note of this. When you're constructing a table and you're not given points, like the last table, the first table we did when we started this lesson, 2 x values were given to you and a y value was given to you, and you were just asked to find the missing values. But when we're actually creating our own table, as opposed to being given a table, when we're creating our own table to use for graphing, we have the freedom to choose our x numbers. Okay, we have the freedom to choose our x numbers, and typically we want at least 3. We want at least 3 x values. Okay, at least 3 x values. Okay, I don't know if you can tell if that's an A or not. At least 3 x values. Now, whatever numbers you put over here, whatever 3 numbers you put over here for x, you are free to pick any numbers you like. Any numbers you want to use can be used over here. However, I suggest that you use -1, 0, and +1. Those are the numbers that are most commonly used, other than maybe 1, 2, and 3. -1, 0, and +1 are the numbers that I suggest you use when you're constructing your own table of values for your x values. Okay? Because it's just easy to add, subtract, multiply, and divide with 1s and 0s. So it just makes our calculation easier. So now, all we're going to say is if x is -1, if x is a -1, then -2 times a -1 plus 5. Okay, -2 times a -1 is a +2, plus 5 gives me a 7. Okay, so when x is -1, y is 7. Then I plug in a 0, so I say I have a -2 times 0 plus 5, because x is 0. So when x is 0, -2 times 0 is 0. 0 plus 5 is 5. Then I'm going to plug in a +1 for my x. So I go to my equation. Y equals all of this. So y equals a -2 times x plus 5. So y equals a -2 times 1, because now x is 1. So -2 times 1 plus 5. -2 times 1 is a -2. -2 plus 5 is a +3. Okay? So I've completed my table of values because I have 3 coordinates, 3 points. Alright? And that's what I want you to understand, that these are just coordinates, they're just points. So I have a -1, 7, 0, 5, and a 1, 3. So now I'm ready to construct my graph. Excuse me. Didn't mean to put it there. Ready to make my graph. Okay? So what I have to understand is, when I'm looking at my points will determine, if I'm having to create my own graph, how many hashes or how many grids I need my graph to have going each way from the origin. Well, because 7 is the biggest number, positive or negative, we don't care. 7 is the biggest number in our table. We need to make sure we have at least 7 grids going in each direction. So it's 1, 2, 3, 4, 5, 6, 7. So let's say I need to be about right here. Okay. So I'll go from up here to down here, and from over here to out here. Alright, we need at least 7. Now hopefully I got 7 on here, but 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Alright, so we have our 7 because our biggest number was 7 here. So we plot our points. The first point is -1, 7. X is -1, Y is 7. So we go back 1, up 7. So that gives us our first point, which would be right here. Back 1, -1, up 1, 2, 3, 4, 5, 6, 7. There's our first point. Our second point is at 0, 5. So 0, 5, this is known as an intercept. Okay? Because if you notice, 0, 5, 0 means I don't go in any direction for the X. I don't go right, I don't go left, because X is 0, so I stay at the origin. However, Y is 5, so I count up 1, 2, 3, 4, 5, and I make my point. And notice, this point is actually on the Y-axis. Okay? This point is on the Y-axis. So when you have a point on the Y-axis, it is called a Y-intercept. Okay? Anytime you have a point on the axis, it's called an intercept. So a point on the Y-axis would be called a Y-intercept, and a point on the X-axis would be called an X-intercept. Now, our last point is 1, 3. So we go over 1, up 3, make our dot, and there you have it. There's your line. Notice how I have the arrowheads at the ends of the lines to indicate that these lines are continuous. They go on forever, so that's very important. Okay? So there's your line. So that line represents the equation y equals -2x plus 5. This line represents this equation. There it is. So we've graphed this equation using table of values. Okay, so let's try another one. Just give me a minute to finish erasing. Put my line back up here. Okay. Now hopefully the ones we do won't be any more than, won't need any more space than this, but we'll see. Alright, so now let's try, let's say this one. Y equals 3x. Alright, y equals 3x. This should be a pretty straightforward one. It's already in solve for y, so that's our first step, solve for y. It's already got y by itself, so we can construct our table. Again, we're going to use, we get to pick our 3 x's, we get to pick at least 3 x's. So -1, 0, and +1. Again, we pick these numbers. So if you like numbers better than these numbers, then you use those numbers. You could put 13, 18, 22 over here if you wanted to. It doesn't matter. Okay? Just consider that whatever you put over here is going to affect how big or how small your graph is. So again, I recommend that you just stick with -1, 0, or 1. These are basic numbers. Alright? So now, if my x is -1 If x is negative 1, that's like saying negative 1 times 3, which is a negative 3. So when x is negative 1, y is a negative 3. My 0 right here for x. Well, if x is 0, then 0 times 3 is 0. So if x is 0, y is 0. And then my 1, so if x is 1, then 1 times 3 is 3. And there you go. So if x is 1, y is 3. So I have my 3 points. So I can plot my points. Okay. So negative 1, negative 3, and when again, I want to just make the point, if you're looking at the table of points, the table of values that you have to plot, your biggest number is 3, regardless of it being positive or negative. The biggest number over here is 3. So you would only need to make a graph that had 1, 2, 3 hashes. 1, 2, 3, 1, 2, 3, 1, 2, 3. You would only really need to construct a graph that had 3 hashes going each way from the origin. Okay? So we have our first point, negative 1, negative 3. Here it is. Our second point is 0, 0, 0, 0. So there it is. Our last point, x is 1, y is 3. Go over 1 for x, up 1, 2, 3 for y. Make your dot. And here I'll actually use the line to do it, hopefully. Get it right by doing this. Alright, and there you have it. Okay, so there's a graph. So this line represents the equation y equals 3x. Alright, let's try another one. So now let's try, what's a good one? Let's see. Let's try y equals a negative 1/3 x plus 2. Y equals a negative 1/3 x plus 2. Alright. The beauty of this equation here is, again, it's already solved for y. Y is already by itself. We go to construct our table set up, so now we want to plug in our numbers. But notice, this time, instead of plugging in negative 1, 0, and positive 1, now I'm going to plug in negative 3, 0, and positive 3. Now, this is something you want to make special note of. Make special note of this. When you solve your equation for y, when you do this step, and once you've done that, you notice that your x has a fraction for a coefficient. Notice, my x now has a fractional coefficient once I've solved for y. I've solved for y. The equation is solved for y, and my x is attached to a fraction. Okay? So, once I find out, after solving for y, once I determine that my x has a fraction for a coefficient, then instead of using our negative 1, 0, and positive 1, instead of using negative 1, 0, and positive 1, which are our normal numbers to use, we want to use 0 still. We still want to use 0, but instead of the negative 1 and the positive 1, we want to use the negative and positive version of the denominator of the fraction. Alright? We want to use the negative and positive version of the denominator of the fraction. Okay? So, in this case, the denominator is 3. So since that denominator is 3, instead of using a negative 1, 0, and positive 1, I use a negative 3, 0, and positive 3. And what this does, it allows me to get rid of the fraction. Okay, because when I plug in, I'm saying y equals negative 1 over 3, and x is a negative 3 plus 2. Negative 1/3 x, and we're saying x is negative 3 plus 2. Now, all we're doing is multiplying the negative 3 times the top. So negative 3 times the negative 1, okay, is a positive 3. So now you're looking at y equals a positive 3 over the 3 that's still in the bottom. Negative 3 times the negative 1, negative 3 times negative 1 is positive 3, and you still got this 3 on the bottom. Alright, well 3 plus 3, I mean it's not 3 plus 3, 3 over 3 just cancels. Alright, 3 over 3 is the same as saying 1. Okay, so you have your y equals 3 over 3 plus 2, and we say 3 over 3 is 1. So y equals 1 plus 2. Alright, so y equals 1 plus 2, and 1 plus 2 is 3. There you go. So notice, once I plugged in that negative 3, it allowed me to get rid of my fraction. Notice, it turned into a whole number, to an integer. Alright, so when I plug in negative 3 for x, y is 3. Now if I plugged in 0, so that's negative 1/3 times 0 plus 2, well 0 times anything is 0. Okay, so you would have y equals 0 over 3 plus 2, and 0 divided by anything is 0, so that would be 0 plus 2, and 0 plus 2 is just 2. Then lastly, now you're going to plug in a positive 3, so y equals negative, a negative 1/3, now times a positive 3 plus 2, y equals, now 3 times a negative 1 is now a negative 3, and you still got the 3 on bottom, plus 2, and a negative 3 divided by 3 is a negative 1. So you now have negative 1 plus 2. And negative 1 plus 2 is 1. So there are your points. So this would be another graph where all you would need is 3 hashes, because 3 is the biggest number present. So 1, 2, 3 hashes, 3 hashes here, 3 hashes this way, 3 hashes that way. So the first point is negative 3, 1, 2, 3, up 3, 1, 2, 3. There you go. Second point is 0, 2, and we talked about that. 0, 2, this point is on the y-axis, so it's called a y-intercept. Alright, this point right here, because it's on the y-axis, it's a y-intercept. 0, 2, and then you have 1, 2, 3, up 1. 3, 1 is your last point. We connect the dots, and let's see here what we get. Okay, that's not the best line, but close enough. Alright, so there's our graph. Okay, and this graph represents y equals negative 1/3 x plus 2. This entire line is that equation. Okay, let's look at one more. Let's look at one more. Okay, let's see here. What do we want? This will be a good one. Okay, erase this. Just bear with me while I erase this. Alright, so now let's say we want to use, we have an equation, negative 2x plus 4y equals 8. It's a good one. Okay, you have that. First of all, let me get rid of these other points over here. Let's see. Get rid of that point. There we go. Okay, so negative 2x plus 4y equals 8. First step, solve for y. So we got to get y by itself, so add 2x to both sides. So now you have 4y equals 8 plus 2x. Again, these are not like terms. These are not like terms, so you can't combine them. So you just write them out, and we want to write the x term before we write the constant term. So the x term is the positive 2x, and the constant term is the positive 8. So 2x plus 8. Y is still not by itself. You have this 4 here, so you have to divide by 4. Divide by 4. Divide by 4. So now what you get, and pay close attention, you end up with y equals 2 over 4. And you do not write 2 over 4 because 2 over 4 reduces down to 1/2. So you write 1/2 x plus 8 over 4, which is 2. So 1/2 x plus 2. Y equals 1/2 x plus 2. Alright, so this will be the equation we're working with. Now, again, next we want to construct our table. So we're ready to put our numbers in to construct our table. So here, I told you with the last problem, instead of using our -1, 0, and +1, remember, -1 and 0 and +1 are the numbers we normally use. -1, 0, and +1. But that's only if the coefficient for x is an integer. If the coefficient for x is an integer, after you solve for y, then you use these numbers. But if we notice, we've solved for y, we've got our equation in the proper form, it's solved for y. Now I have a fraction for a coefficient for my x. I have a fraction for a coefficient for my x. In other words, my x is attached to a fraction. Alright, and because of that, instead of using -1, 0, and +1, I'm going to actually use -2, 0, and +2. So I won't use these. Okay, because again, using the -2, 0, and +2 allows me to get rid of this fraction. So first I say y equals 1 over 2, and x is a -2 plus 2, and a -2 times 1 is a -2 over 2, so that's y equals a -2 over 2 plus 2, and a -2 divided by 2 is a -1, so y equals a -1 plus 2, which equals 1. Okay, -1 plus 2 is 1, so y would equal 1. So there it is. Then I plug in my 0, so y equals 1/2 x, x is 0, plus 2, y equals 0 over 2 plus 2, y equals 0 plus 2. 0 plus 2 is just 2. Then I write y equals 1/2 x, and x is 2 plus 2. And this 2 times a 1 is 2, so 2 over 2 plus 2, which equals 2 over 2 is just 1, so 1 plus 2, which is 3. There you go. Okay, so again, when you're multiplying, filling in your x, and you're multiplying by a fraction, you just multiply it by the top, and then whatever number's in the bottom of the fraction, then you divide. So times the top divided by the bottom, times the top divided by the bottom, times the top divided by the bottom. Alright, so we have our points. So we have a -2 up 1, we have 0, 2, again a y-intercept, and we have over 2 up 3. And just to expedite things, I'll just go ahead and graph it myself without using the little line. Alright, so there it is. There's our line. Y equals 1/2 x plus 2. There you go. Now, there's one additional thing I want to point out to you before we wrap this up. Let erase. Okay. One last thing I want to point out. Okay, and that is when you're given an equation where it's only one variable. So let's say you have y equals 4. So if you notice, that equation just has one variable, it doesn't have an x in it. Y equals 4, period. Alright, so you're wanting to graph that. Now if you're trying to use table of values to graph an equation like this, this is saying that y is always equal to 4. So since we know we need at least 3 points, then we write 3 fours. We write 4 3 times because we know we need 3 points. And like we've already said, that we use our common numbers for x, -1, 0, and +1. Okay? -1, 0, and +1. If y is 4, then we write 4s, 3 4s under the y column, and then just write our -1, 0, and 1 for our x. So -1 up 4, 0 4, which is a y-intercept because it's touching the y-axis, and over 1 up 4. And there you have it. This would be the line of y equals 4. Now, let's say, on the other hand, if you had an equation like x equals -5, okay, and you're needing to use, again, table of values, x equals -5, and it's just one variable, x equals -5. Well, that means x is always going to be -5. So if x is always going to be -5, you write your 3 -5s, because this is telling you x is -5. So you write 3 of them. And then since you wrote the -5s on the x side, now you're free to just say, okay, well, on the y side I'm going to write my -1, 0, and +1. Okay? So plot those points and you see x is -1, 2, 3, 4, 5, -5 -1, there you go, -5, 0. Now, this is good. Here we go. This point is actually on the x-axis. This is on the x-axis, so this would be considered an x-intercept. X-intercept. Remember, we already talked about when a point is on the y-axis, it's actually on the y-line. It's called a y-intercept. Well, this point here is on the x-axis, so it's an x-intercept. Okay? And then our last point is -5 + 1. So there you go. Connect the points, and there you have it. So this would be the graph for x equals -5. X equals -5. There you have it. Alright, now, simply put, instead of using a table of values, at the end of the day, all you really care about is if y equals a number, then you're going to get a horizontal line through that number. So we said y equal 4, and notice we made a horizontal line through 4 on the y-axis. 1, 2, 3, 4 on the y-axis. So we made a horizontal line through the number 4 on the y-axis. And conversely, if x equals some number, then you're going to have a vertical line. You're going to have a vertical line through that number. So the problem we had was x equals -5. So all we did was go to the x-axis and count -1, -2, -3, -4, -5, and just write a vertical line, straight up and down line through -5. And there you have it. So it wasn't necessary for us to use the table of values, but if we were asked to, this is how you would do it. But simply put, if I had x equal 1, then I could just go to 1, which is right here on the x-axis, and I would just draw a straight up and down, a vertical line through 1, and that's x equals 1. And I didn't have to use a table of values to do it. Okay? But if I did use table of values, x is 1, so I'd write a 1, a 1, and a 1, and on the other side, -1, 0, and +1. Okay? So that will wrap up our lesson on graphing using table of values. Again, this is our first graphing method. Altogether for this class we want to go with a total of 3 methods, and we'll have follow this session up with some other sessions to talk about the remaining 2. So at this time we will conclude this session.